On Friday, we looked at law of cosines. I think everybody was doing pretty well with that. At least as a group, you guys were able to come up with the right answers. I'm sure that probably your biggest question is just that ambiguous case, making sure that we check through it. So we'll continue to look at that a little bit whenever we do the word problems as well. But right now, we're going to look at the law of cosines. So the law of cosines is printed there for you. And it looks a lot more complicated than the law of sines. However, I think you will find that as we do these problems, lots of them I think are actually easier than the law of sines problems. And the great thing about law of cosines is that there is no ambiguous case with law of cosines. So for you to use law of cosines, you're going to have one of two types of triangles. You will either have, it's got to be used whenever you have two sides and the included angle. So that would look like this. You would know maybe this side and this side, and you would know the angle in between them. The other time that I did not list here, but also is the case, if you know all three of the sides, you can also use you also have to use law of cosines. So you'll notice that there are three different versions of the law of cosines, but really it's the same. You could just label your A, B, and C differently. So like if I have A squared, then it's going to equal B squared plus C squared minus 2BC cosine A. Notice the A over here matches the angle A over here. And then your other two, you got B and C showing up here. Well, if you want to know angle B instead of angle A, you got your B here, your angle B over here, and then in the middle, you got your A's and C's show up. The great thing about this, too, is it really doesn't matter which one you call A and which one you call C, because since you're squaring them, adding them together, multiplying here, all of those operations are commutative, where it doesn't matter what order you do them in. So it doesn't matter which one's A and which one's C there. And then, of course, down here, C, or here, you got A's and B's in the middle. I will give you the law of cosines whenever we take quizzes or tests, because most everything I think you're going to run into, if you have law of cosines, they're going to give you the law of cosines to use. I think most ACT practice problems I've seen, they give you the law of cosines if it's a law of cosines problem. So I don't think it's something necessarily that we have to have memorized. Yes, you can. Yes, you can put everything in at once. Yeah. Yeah. So let's do a problem here. So we have, in this case, we've got angle A, we've got side B, and side C. So sometimes, like right now, obviously we're going to be using the law of cosines because these are the law of cosine notes, and I'm going to teach you how to do the law of cosines. But when we get to the word problem worksheets that we're going to see tomorrow, they're going to be all mixed in together. It's not going to tell you use law of sines on these and law of cosines on these. So you have to look at the situation. So like if I tried to set up law of sines, I would have sine, I'd have to use 98 because that's the only angle I've got, over A, equals, but then I don't know angle B or C, so it would look like this. I'd have like sine B over 12, or maybe I might do sine C over 15. But am I going to be able to solve this whenever I have two variables in the equation? I cannot. So I cannot do law of sines. So if you can't do law of sines, law of cosines must be what you need. So in this case, law of cosines, we're going to have A squared is going to equal B squared, which in this case our B squared is 12 squared. Our C squared, which is going to be 15 squared, minus 2 times B, which was 12, times C, which was 15, cosine of 98. So the great thing about these problems is that you can just type all that into the calculator. You don't have to do it piece by piece. The calculator can handle it. So we're just going to type this in. 12 squared plus 15 squared. Did I record? Yeah, okay. Good. 2 times 12 times 15 cosine 98. So you type all of that in, and I got 419.102. Am I in degree mode? Yes. So A squared is going to equal 419.1023163. You don't have to necessarily write it down, but keep that number in your calculator, because are we finished? Is that our answer? It's not. So what do we need to do last? Square root. And so if we take the square root of this answer, then we got 20.472. There is no ambiguous case with law of cosine, so you never have to check for it. There's always just going to be one answer, and you basically just type it straight in. So I think that these types of law of cosine problems are pretty easy, pretty straightforward here. So, so even though the equation looks a little confusing, it's not so bad. Let's look at this particular case. So we haven't looked at a lot of application stuff yet, just a couple problems, but we're going to work our way towards that because there are a lot of different places where law of sines and cosines apply. So in this case, we got car A and car B leave the same point at the same time. Car A travels north on a straight road at 60 miles per hour. Car B travels 20 degrees south of east on a straight road at 45 miles per hour. After 2 hours, how far apart are the cars? So, we're going to have north, south, west, and east. And the easiest thing to do here is to let the point that they both leave from be right there at the origin. Alright, so we're at this point right here. Car A is going to travel north on a straight road at 60 miles per hour. So car A is going north. So this one right here is car A. And car B travels 20 degrees south of east. So whenever you're doing this south of east, your main direction is east. And you're going 20 degrees to the south of that. So that will look like this. This will be 20 degrees to the south direction of east. There. So, we want to know how far apart the cars are. So, let's say this is a police chase here. Of course, everything we're going to do is going to be super oversimplified, but Josie robs a bank right here, and she takes off straight north. The cops thought she went this way, and they take off down here 20 degrees south of east. 2 hours later, they realized she went the other way. So if we want to know how far it is from here to here. So let's say this at this place right here at the robbery. There were maybe 2 white cars that left, and this white car went north. The helicopter actually followed this white car, right? Because this is a high stakes robbery right here, and the helicopters are out. So if the helicopter is down here, it obviously needs to try to go this direction to find the robbers. So we want to know how far it's got to go. All right. We've got to know how far car A and car B have gone here. So how far did A go? 120 miles. Because at 60 miles an hour for 2 hours, it would be 120 miles. How far did car B go? 90. And we want to know this side right here. We want to know that red side, how far it is from A to B. And so, we've got a triangle here. Do I know any of the angles of the triangle? Okay. I can find it really easily. It's not 20 though, right? What is this angle right here? 110. Okay. Because we know that north and east are going to make a 90-degree angle. We add that extra 20 degrees to it. So we want to use 110 as our angle here. We cannot set up law of sines because it would be 110 over x, but then I don't have any other angles to set this up with. So this is a law of cosines problem. So we would say, here we'd say x squared is going to equal, it does not matter which side you call A or B. Technically, I guess if we're calling this angle A here, it would be 90 first, but it doesn't matter. 90 squared plus 120 squared minus 2 times 90 times 120 cosine of 110. And so all of that has to be typed into the calculator. Okay, so I get x squared is 229,887.6351. Is this my answer? No. Square root both sides. And 172.88 miles. You can call, since I labeled it X in my picture, I just called it X, but if you call it C, that's fine also. So you can use whatever variables you want to use there. And so the helicopter, since it can go really fast, it could probably catch up fairly quickly there. Yeah, that's sort of like an oversimplified situation, but it could be. Because more than likely, you're not going straight on the highway for that long. But it gives you an idea. Okay, questions on that one? Okay, for this one, we've got only sides. We don't have any angles. So these are not super difficult, but they are a little bit tougher than the other two that we have done. So we've got x, y, z. I'm just going to draw me a triangle here. So x would be 14, y would be 19, z would be 22. So now this time we have to find the angles, and we need to just pick one of these angles to find first. It doesn't matter which one. Major, which one do you want to pick? Z. All right, so if we're finding Z first, then that means side Z, which is 22, needs to be over here on the left-hand side. And that means 14 and 19 are going to be our A and our B here. So it doesn't matter which one's which. 14 squared plus 19 squared minus 2 times 14 times 19 cosine of Z. Now, this one we can't just type in because our Z is way over here. So we've got to actually kind of solve this. So 22 squared is going to give us 484. 14 squared is what? 196. And 19 squared is 361. We got to do 2 times 14 times 19. So give us 532 cosine of Z. And so I'm trying to get that Z right there by itself. I could have went ahead and put 196 and 361 together if I wanted, but I'm going to do that now. So that's going to give me 484 equals 557 minus 532 cosine of Z. Can I put 557 and 532 together? No. Because I got that cosine Z beside of my 532. So I cannot put those together. What I'm going to have to do now is subtract that 557. So I get negative 73 equals negative 532 cosine Z. And so I will divide by the negative 930 or 532. So it'll give me 0.13721. Keep that in your calculator, equals cosine Z. And then what do I have to do after that? Inverse. So I got 82.113. And that was my Z. Okay. Questions? Alright, so we're not done because it asks us to solve the triangle. So it wants us to find all of the angles. So what we could do is we could go back and we could do law of cosines just like we just did, except for we could do it for x or for y. Or, at this point, because we know this angle, because we know this is 82.113, what else could I do? I could use law of sines, right? So I could say sine of 82.113 over the side across from it is 22 equals, I can choose x or y, does not matter here. I think I'll choose x, so sine of x over 14. And you're going to cross multiply 22 sine x. It's going to equal 14 sine of 82.113. We'll divide by 22. So sine of x is going to equal, calculator, 14 sine of that answer divided by 22 is 0.6303. And how do we get rid of sine? Inverse. And so sine inverse is going to give us 39.076. Okay. We are still not finished because we need to know y. And to find the measure of angle y, I just need to do 180 minus the two angles I already know. So 180 minus 82.113 minus 39.076 is going to give me 58.8. Yes.
So I store them into the calculator or whatever, like we did before.
Yes. Did you get a different answer for x? I used the exact answer, so they should have been the same. What variable do you store yours as? Okay, let me see. Maybe. Okay, so then if you do 14 times sine of c. Here, do the same thing as me this time. You know what? You may have done. You don't close that parentheses right there when you divide by 22. It's going to be a different number, and that might be what you did. Okay. All right. Questions. These are kind of lengthy, but there's no ambiguous cases, and you can revert back to law of sines if you prefer doing that. There. Okay, questions? Okay, so your assignment today is a worksheet, and we may get finished, and I may go run off the word problems because the word problems are going to take you longer, and you're probably going to have more homework tomorrow. So if you finish this, we may move on and start some more problems. We got through next really quickly. Good. We're behind. Okay, so on this worksheet, I want you guys, let's do, on this worksheet, I want you guys to do number 1 through 12 all, because on 1 through 12, you've only got to find one thing. It's not asking you to find all the sides and all the angles. So like on number 1, it's asking for AB. So it's just wanting that side AB. So let's do 1 through 12 all, and then I want you guys to do number 13 and 15. So you'll just have a couple of these that you've got to solve the entire triangle for. Okay, questions? 1 through 12 all, and then 13 and 15. Okay. Think those in text.